Welcome back to the Pat Long Codes YouTube channel. In today's video we're going to be talking about 4 basic types of joins using the pandas library in Python using pandas data frame objects. Without further ado, let's go ahead and get started by showing you how to access Google Colab, which is where we'll be using a Jupyter notebook from in this tutorial. So yeah, you just go to, in the Chrome browser, it's easiest if you just go to Google and just search for Google Colab. And then you'll see this welcome to Colaboratory. And once you get to this page, just go ahead and sign in and you're all set to get started in Google Colab, assuming you have a Google account or Gmail account. If not, just go ahead and get one and you can use this tool. I'd recommend just using it, and that's what I'm going to use in this video just because everything's already installed. It alleviates the problem of people not having the most recent version of pandas installed or the most recent version of Python installed. So yeah, if you just go ahead and use this tool for now. Of course, if you already have Jupyter or a recent version of Jupyter, you can go ahead and run the code that's in this video on your local version. But yeah, I'm going to be using this tool, so let's jump right into the next part and get started with the code. Here I am in my notebook here. I've already written some things to get started. I'm going to be using, so these are the only libraries we need to use. I'm just using sklearn from scikit-learn data sets as example data that are easy for anyone to access and use rather than downloading a CSV file or something of that nature. So I'll just be exclusively using some data sets from there in my examples. Now I'll also periodically use the df.describe method in pandas just to look at the shape of the data we're going to be looking at. So I'll start off by importing these libraries. And first off, the first type of joints we're going to be talking about is inner joints. And I wanted to have this Venn diagram here to illustrate that we're talking about here the intersection of these two, in our case, data sets. So in set notation, we want the intersection of two sets for this inner join. So I'm going to do 2 examples using Fish's iris data set. The first one, I'm going to focus on using a column that they have in common. I'm actually going to make up this column. So just follow along with me. Sorry, I haven't mentioned this yet, but all the code used in this tutorial is in the linked in the description below. But you can follow along. I'm going to be typing as I'm speaking, so you can follow along with what I'm doing here. So I'm going to load this iris data set. Also, just want to, before we really get into it, I want to show you another tool that's cool with these toy data sets that are on here. If you're unsure about the background to these data sets, you can use this description part. This is kind of like a dictionary object, what we're loading in here, not a data frame. And there's like a lot of different keys you can you can print and you can find information on it. This one I'm going to print is a description of the data set, so you can get information like the columns that are on there. You use this for a classification problem. In machine learning, that's not the purpose of this video, but just mentioning it. And so you just, with this description, you get a lot of information and background. If you've not heard of the iris data set before. Here's some further background on it. And that goes for all the other data sets we're going to be using in this tutorial. I'll just comment that out because you might not want to see that. This is a bit of a caveat, but just thought I'd mention it. I won't go into that detail with the other data sets we use. So now I'm going to convert that into a now it's like a NumPy array. I'm going to convert it into a data frame. And let's, so pd dot data frame, and sorry, I put a comma instead of a period there. So pd dot data frame, and again, like I access this description here, I'm going to use iris dot data, which is another one you could print. It would just look like an array, and then I'm also going to want some column names that I can also access here. So columns equals iris dot data. Iris dot feature names. Feature names, yep. Feature names, cool. And that'll give us our iris, this data frame called iris df. There's a target column. I'm going to add that in there, and what I'm doing here will make some more sense when we visually look at what we do here with the joins iris dot target. And so I'm going to create, I'll just copy and paste that. I'm going to create a column called iris ID, which we're going to use for our join down the line. So I'm going to call it iris ID, and we'll use the range function so that we get so that it's between 1 and the length of this data frame, which happens to be 150. So we're going to use the length function here, and iris df, and we're also going to add 1 because it's 0 index. So we're going from 1 to 150 instead of 0 to 149. That's why I added the 1. And we also want, I'm also, just to make it easier to follow, I'm going to create a column called target name, which is the type of plant that's in this data set. Again, you can look for more information on the intricacies of this using the print iris.df description. But for now, we'll just gonna have to use so I want to use the target and map it to this target name. So I'm going to use lambda here to map the target to these target names that are 3 different names for the different types of iris plants, I believe. Okay, and now let's just take a look at what this looks like. Make sure I haven't made any typos so far. Again, I'll probably comment this part out, but yeah, I'm going to use so I'm going to use head here to get the first 5 rows of the data frame. Sorry, what's wrong with my syntax here? Oh, yes. It's missing a very important thing. There we go. That should solve it. Oh, still got problems. lambda. There we go. And oh, I don't know when I pulled that in there, but I don't think I wanted that. I'm trying to just keep it simple, so we just have these. Must have accidentally auto-typed something in there. Okay. All right, there we go. Yeah, so here you have that target name column I was talking about that we want. So yeah, that's looking good. Okay, and we'll proceed to what we're actually here to do, which is a join. So I'm going to make two sort of subset data sets here, pretending like these came from different sources, but have this this iris ID column in common. Again, bear with me, and we'll take a look at what that will entail. So I'm going to drop some columns from the left table here, which I'm going to call iris df1. I'm going to do the drop method here. I'm going to drop just the target column here. And yeah, I'm going to want axis equals 1. And then I'm going to do a similar thing for iris df2. But I'm going to take all these columns, the columns with the data we're really interested in, the sepal length, the sepal width, petal length. I just copied and pasted them there just to make this a little easier. So that this is a list. So I just have to put commas in between each item in the list. Okay. So that's our second. So this is in our join. We're going to be thinking of this as the left set, and this is the right set. So right now they both will have 150 rows, which won't tell us too much about what we're thinking of at this intersection when we're talking about an inner join. So one thing we can do to sort of simulate them having different sizes and different iris ID values is to take a sample of each. There's a sample method in pandas that's very useful for sort of doing something like this. So I'm going to take sample, dot sample, and just take the sample using this n equals parameter. I'm going to take 50 from the first one, and then 50 from the second one. In all likelihood, it'll be a different 50. So when we join them together, again, we're doing an inner join here. It will be somewhere between 0 and 50. So I'm going to make a final data set called merged iris df, and I'm going to use the merge method here, pd.merge, and we're going to make sure we want I think it's best practice here to call this something else. Let's call this let's call this iris sampled df1. Sorry, it's getting a bit messy here. And let's call this guy iris sampled df2. And I think that'll look a little better, and you can see the difference between the two of them if you wanted to print them or use the .describe method. So okay, we're merging the iris sample df1 and iris sample df2. Where we've taken the subset of these two data frames up here. They have different things in them. One is this one where we dropped all these columns is basically just has the target and the target name, and of course the iris ID, which is what we're going to be joining on. And then iris df1 is just missing the target. It has everything else. But for this scenario, we're kind of pretending they're coming from different data sources, but they have this iris ID column in common. Okay, so now. So for the parameters for the merge method, we're going to want how here. So how is how is the join. So this is inner, and we're going to do it on, of course, the iris ID, which is what the two different data frames have in common. So iris ID. Okay, and now we're going to do print merged iris df to take a look at what that looks like. I'll just comment this one out for now. And so, yeah, because of what we said here, again, so we've got this set of 50 and this set of 50, and we're just going to be looking at what they have in common. So it's probably going to be somewhere, in terms of the size of the data frame, between 0 and 50. Yeah, so we have these 14. So our inner join data frame has 14 in common. And yeah, because we have some duplicates here, the pandas has gone ahead and assigned us target name X and target name Y. So X being from the left side and Y being from the right side. So it automatically does that. I also wanted to mention that. But we don't have any other duplicate columns because our left data frame, which we called iris sample df1, had all these in it, and the iris ID, and our right side just had the target. They both had the target name and the iris ID, which is what we joined on. So cool. I think that's a pretty solid example. There was a little bit of excessive manipulation, but this is a totally reproducible example that we can use with the iris data set. A second method I want to mention is doing an inner join using left and right index. So I'm going to take exactly the same code, but I'm not going to take the sample. So I'll go ahead and take all of this from up here. So I'll go ahead and take all of this from up here, but we'll do a different merge. And in this scenario, I'm not taking a sample. We'll just get the whole 150 and join them together. And we're not going to be using, actually we don't even need this iris ID because we're going to be using the index. If you're in a happy coincidence of two data frames having the same index, this is a method you can use to do an inner join. So yeah, we could keep target name, I guess. Yeah, so let's go. Yeah, we'll just get rid of target name. We'll simplify it. Okay. And we'll do this merged. We'll do another merged. All right, we'll call it irisdf as well. And we'll do pd.merge. And this time we'll do these two. And this, instead of up here where we did how, we're going to do left index equals true and right index equals true. So left index equals true and right index equals true. And we're going to also specify how, just like we did in the previous inner join example. Sorry, that needs to be a string. Okay, and yeah, we can just print that and see what that looks like. Or yeah. Print. Okay, cool. Cool, and you see we get a simple join with all 150 rows, and this one in this scenario to look at other types of joins. First off, with a left join, and we're going to use a different example data frame here. But again, we're going to be using these toy data sets from scikit-learn. And here with the left join, again, essentially we're taking everything in table A, everything that it has in common with table B, but excluding stuff that's unique only to table B. Okay, so, and we're going to be using the diabetes and Lineroot data sets. So let's, and we're also going to use this for the right join just to illustrate the difference between the two. So diabetes equals this data sets dot load diabetes. And Lineroot yep. Okay, and we're going to want to make data frames out of these. So we're not using Boston, we're using Lineroot. And so I'm going to call them diabetes df equals pd.dataframe method, and I'm going to take diabetes.data as my data, and then I'm going to want to also use columns. Columns, right? Columns equals diabetes dot feature names, which I spelled wrong. Cool. All right, and then I'll let me call this diabetes df. And I'll do the same for Lineroot. I'll just replace diabetes with Lineroot. Sorry, I need to change that to data sets dot load Lineroot. That would be. Let's just fix that. All right, cool, good to go. And of course, we need to then change these. Make sure we get the right data frame. Again, you can use, look at the description of these. To see what exactly is in these two data frames. One is patient's diabetes outcomes based on some other data like age, sex, BMI, and the other one is a sample of I think it's 20 people and the amount of chin-ups, sit-ups, and jumps they can do. That's the Lineroot data set. So I'm going to join them and pretend that there's some sort of ID that combines the two. I'm just going to simulate having an ID that, so we can show examples of, what a what a left joint and a right joint and a full joint look like between these two data frames. Okay, so let's go ahead and make this ID column. And I'm just going to write a note here to so we're going to use random permutations using the NumPy library here. Sorry, I don't know why I did that. I don't want that. Yeah. So I'm going to make this. I'm just going to call this ID. So as if there was a person ID, and you can join these two data frames based on that. So I'm going to use np.random.permutation, and I'm going to do it on the index of the diabetes df. You can just access the index like that if you spell it right. Index. There we go. Okay. And I'll just do the same for. I won't bother putting a note there. Actually, I'll just leave that. I'll do the same for the linear df. Okay. So now they both have this ID column, which is different. Let's take a look at what a left join looks like here, and then we'll look at our results by looking at all three data frames here. So left join df is what I'm going to call my data frame, the results from this merge. So I'm going to do pd.merge, and first off we'll do the diabetes df, so that's like our left table. And then I'll do the linear df, that'll be our right table. And I'm gonna do, now the next parameter is gonna be how equals, and we're gonna say left, so this is left join. And then of course, left join on, this could be a list of things, but in this case we just need it as on equals ID, and we're all set. Now just print the results, and we can sort of discuss the results a little bit. So let's print all three data frames here. So this is the left table. Print the right table. Red df, and then we'll print this guy too. So that's the result of our left join. And so let's take a look at these. Hopefully there's no syntax errors. And there is. What did I do wrong? Oh, of course, yes. It doesn't have an object data frame. It needs a uppercase F here. Okay, so let's try that again. Oh, and I need to close that. Okay, let's try again. All right, cool. So here we see, let's start up top. So this is our diabetes data frame. It has all these columns: age, sex, BMI, blood pressure, and these values. Not 100% sure what they are. You'd have to. You could look this up yourself. And this ID column that we made, that's meant to be something we can join them based on pretending that this patient ID can join with the patient ID from the linear data frame. So here we have 442 rows in our left table, and then in our right table, this is the linear one. Again, we have this ID column that only goes from 1 to 20. And it's so we only have 20 rows in that data frame, but our resulting, because we're doing a left join, our resulting data frame has the 442, and you'll notice for chin-ups, sit-ups, and jumps, it has a lot of missing values, but somewhere in between there, we'll have valid values. So I just want to transition directly into a right join with exactly the same data, with exactly the same data frame. So we're not going to do any more pulling data from the scikit-learn toy data sets. We'll go straight into a right join. Now we're looking at everything that's unique to the right table, but also what it has in common with the left table, but excluding everything that's unique to the left table in terms of rows. So let's now look at this, and we'll call this right join df. So right, if I can spell that correctly, right join df, and we'll do this on right. Right. So all we changed there was how we're doing the join. It's a right join. And then we'll look again. We'll print out these first two. You can also use the dot display method to get some descriptive statistics from the three different data frames. Here, I'm just going to print them. We'll take a look at them. Okay. So again, our diabetes data frame has those 442 rows. Our linear data frame has the 20 rows. Because we're doing a right join now, our joined data frame also only has the 20 rows. So there's no missing values because there's a corresponding value for everything in the left table that there is in the right table. And so for the full join, the last join we're going to be looking at here in this video, here we're going to take everything unique to table A, everything unique to table B, and everything that's in common between the two of them. So if we went ahead and did this, by the way, we call this an outer join too, and that's what we'll put in the how is an outer join. Your result, and I just want to illustrate this first. We'll call this full join. And full join. Just want to illustrate this before we look at anything else. You're going to get, just because of the nature of these data, you're going to get exactly the same result you would with a left join here. You get the 400, you get a lot of missing values for, these chin sit-ups and jump column that comes from table B. But everything that's in table B is in table A, so you get no extra rows. So let's look at a second example. Using the same data, I'll just manipulate the ID column in the linear data frame. So let's make another version of the linear data frame, and we'll call it linear2df. And we'll say it's equivalent to linear.df, but now we'll change a column on this new one. So linear.df2's ID column is we'll cube it. How about that? And then we'll definitely have that'll make for an interesting scenario. So we'll pretend it was the original ID cubed, just for this example. We'll make another full join. We'll call this full join 2df, and here I'll just go ahead and copy this, but then change the right table B, so I like to think of it, to linear2df. And now let's go ahead and print all of these out. Again, I'll change to the names of what I'm printing out. And so this will be linear2df. This will be full join 2df. Okay. Don't think I made any syntax errors. Just go ahead and run all this. Yeah, so I just cubed this column. So you're gonna, so the ID2 will be 8, and and it'll get quite big to numbers that don't exist in the diabetes df ID column. And so we'll take a look at what happens there. Again, we're talking about this full join, where we're taking everything from both tables and everything that's in common with both tables and everything that's unique with both tables. Okay, so was printing out the first ones we did as well. So remember that before we manipulate the ID column, we had the 442 rows in diabetes df. Then the linear df had the 19. But when we combine the new linear df, we end up with a few more rows because we get 454. So although we see a lot of missing values here for the chin-ups and sit-ups, there's also going to be 12 instances where there's missing values for the age, sex, BMI, BP, and so on from the first table. So I just wanted to illustrate that example. Perhaps it would be better illustrated if we looked here specifically at the dot tail, the last 5 rows of this. So let's look at those. Yeah, so here you see these large numbers for the IDs. And I think I caused a problem by running it twice. So it cubed the cubes, so it's got these really big IDs now. Yeah. Well, anyway, the first time you run it, it won't be quite this silly. But yeah, you can see, with the last 5 rows here, you got missing values for those columns from table A. Okay, so I think that will about do it for this video. We've gone through the 4 different types of joins. So we started out with the inner join. We did the left join, the right join, and lastly we looked at a full join all in pandas. So thanks for following along in this video, and see you in the next one. By the way, all the code is linked in the description below, and thanks for watching.